Hello everyone, we are from Group B. Today in this presentation, we are going to discuss about the project like pytorch and TensorFlow. According to our requirements, first we are taking the data set. In this presentation, we are using two data sets. The data set one is the lottery Powerball winning numbers, like it's starting from 2010 and the updated data till 2023. And the data sets that we have taken from this website like data.government. If you click this link, you can see the data set that we have taken. And when it comes to the description of the data set, the problem at hand involves predicting Powerball winning numbers based on historical data. This Powerball lottery is basically a popular game where customers, like participants, select a set of numbers that match them with a drawn numbers to win a jackpot. Our main goal is to leverage machine learning using both TensorFlow and PyTorch to build the predictive models that learn the patterns from historical Powerball winning numbers and make accurate predictions for the future draws. And in this, we are also doing the data processing where we clean and pre-process the data set. And then we are using it for the training and learning the machine learning models. This data set contains historical Powerball winning numbers from 2010. And the main goal for this project is to analyze this data set and understand the patterns of that winning numbers. And then we are building the machine learning models that can predict the future Powerball numbers. The first step involves the data pre-processing. Like we handle the missing values, convert the data types, prepare the data set for the training, and then we split the data into testing and training. And the next step is we use the TensorFlow and PyTorch, and then we train the predictive models. Here we are using the various neural network architectures like tune hyperparameters and then evaluate the model's performance on the testing set. And the final result will be trained model that can predict the Powerballs based on the historical patterns. These analysis of results will include evaluating any challenges that we faced during the process and also reflecting the practicality of the main data set that we are using. First, we have imported the pandas and then we have taken the data from that website. Here you can see that read.csv, the output is here. We can see 53 rows and 3 columns. And then when it comes to data.info, we can see all the data information here like data types, float, and the object and the memory usage. And then the multipliers, including the multipliers applied to winnings. There are no missing values in this data set like draw date and the winning numbers. Approximately, it's like 36.5 KB. And then when it comes to the data pre-processing, first in the same way as the previous things, we have imported the pandas and then we have read the data, and then we are splitting the winning number columns and then creating the new columns. If you can see here, we are using the split function that expands true, like for loop in I in range winning numbers, split dot the shape, and then we are concatenating the pandas data, then we are printing that data. Here, if you see the information that we are going to display in the data frame like data.info, we can see the draw date, winning numbers, multipliers like number 1, 2, 3, all the columns of that data set. And then we can also see the memory usage and everything. Scroll down. The memory usage have been increased like approximately 109.3 KB due to the addition of these new columns. And then the data pre-processing step facilitates further exploration and modeling, particularly when aiming to predict individual numbers in the Powerball lottery based on the historical data. When it comes to the data.describe, we can see all the count, mean, STD, minimum, everything. Here, the multiplier column statistic indicate that there are 1, 3, 4, 3 non-null values with a mean multiplier of approximately 2.81. The majority of the multipliers fall within the common range like 2 to 3, as suggested by 25th, 50 and 75th percentages, and a minimum of 2 and a maximum of 10. And then can you please scroll left the code? Here, then, in the same way, we are importing the TensorFlow. We are using the sklearn model selection, like we are importing the train test split. Then we are assuming the data and then dropping the draw date column if it hasn't been dropped already. We are converting the sets to strings and then one hot encode. Here you can see the code here, like data is equals to data.drop. And then we are dropping the rows with missing values, and then we can see the output here, all the things like 1300 rows and 18 columns. In this provided code, the data frame has undergone further pre-processing for machine learning. The draw date column has been dropped and the winning date column has been one hot encoded after converting the set of winning numbers into sorted strings. The remaining columns include the multipliers number 1 to number 5, number 6 columns, and the new columns represented the winning numbers. This encoding allows the model to capture the individual impact of each winning number on the prediction multiplier. The data set is now suitable for splitting into the training and testing sets, followed by the numerical features and training machine learning models using TensorFlow. Can you please scroll down? And then we are assuming the data here, X and Y data like features, target, variables, and then we are splitting the data into training and testing like X train, X test, Y train, Y test. From this, the pytorch and TensorFlow process starts. And then we are standardizing the data. And then from this we are implementing the TensorFlow or other frameworks. If you can see here, X-train scale, you can see all the array with all the values that are included in this. And then X-test scaled, we can also see the array result here. Can you please scroll down? In the same way, we are building and training a simple neural network using a TensorFlow. Like now we are using the Keras sequential, activating it and the input shape and etc. The history model. Here you can see the epoch is running till with all the loss value and value loss. Can you please scroll down? Here you can see all the epochs, batch sizes, and the validation date of X test scaled and Y test scaled. Scroll down. A simple neural network is a built and trained using TensorFlow for the regression task for predicting the multipliers in the power data set. And this architecture consists of 3 layers. The first layer has 64 neurons with ReLU activation function, and the second has 32 neurons with activation function, and the output layer has 1 neuron for the regression output. And in this, the model is compiled with the Adam optimizer and the mean squared error loss, which is suitable for the regression. And then when it comes to the plot training loss, you can see the plot X label as epoch and Y label as loss. Here you can see the graph. The orange and the blue lines represent the orange line. Can you please scroll down? The orange line represents the validation loss and blue line represents, scroll up, represents the training loss. Scroll down. This suggests that the demonstration is effective learning and potential predictive capability for Powerball multipliers. And then we are importing the matplot library for the graphs, and then the sklearn metrics, importing the accuracy score and the confusion matrix. We are also importing the Seaborn as SNS. We are then evaluating the model on the test set. You can see the Y predict and the Y predict rounded, and then we are calculating the accuracy. In this code you can see all the functions, and then we are plotting the confusion matrix. Here you can see the X label as predicted and Y label as true. Here you can see all the outputs and the numbers. We are also displaying the colors required to it. The code evaluates the trained neural network model on the test set for predicting Powerball multipliers. In this, the confusion matrix reveals the model's performance in predicting the multipliers. The diagonal elements represent correct predictions, while off diagonal elements show misclassifications. The majority of the predictions lie in the diagonal, including that the model struggles to accurately classify the function. And now the pytorch. Can you please scroll upwards? Upwards. PyTorch. And now the PyTorch. Now we are importing the PyTorch and then the sklearn and then the Seaborn and also the matplot library. Here we are splitting the data into training and testing, and then we are standardizing the data. Here you can see the X-train scaled and the X-test scaled, and then we are converting the data to PyTorch tensors. Here you can see the code here. And then we are in this, the dataset features and target variables are splitting into the training and testing sets using the train test split function from scikit-learn. And then we are converting the float 32 tensors, X-train tensor and the X-test tensor. These PyTorch tensors are now ready to use in building and training neural networks models for this production. And here you can see the build and train a simple neural network using PyTorch. Here we are using the simple NN. We are then defining this function, the self, and then we are defining the forward function, and then we are initiating the model. Here you can see the input size and the model. The code defines a simple neural network class using a PyTorch with 3 fully connected layers. This network architecture consists of the output sizes determined by the features in the Powerball data set. And then we are defining the data. We are training the model. You can see the epoch and the loss. The above code defines a mean squared error loss function and the Adam optimizer for training the PyTorch neural network model. The model is trained for 10 epochs on the Powerball training data using a learning rate of 0.01, and the training loop prints the loss for each epoch, indicating the model's progress in minimizing the difference between predicted and the actual values. Here you can see the plotting training loss. The graph represents that. The plot illustrates the training loss over 10 epochs for each PyTorch neural network. Scroll down. And the decreasing trend indicates the model improvement in minimizing the mean squared loss using training, suggested effective learning, and the more accurate production. Then we are evaluating on the test set the confusion matrix. Scroll down. Here the X label is the predicted one and the Y label is the true one. Here you can see the majority of the predictions lie on the diagonal, suggesting that the model encounters challenges in accurately classifying the different Powerball values, and particularly for multipliers 3, 4, 5, which intends to predict values adjust to the true multipliers. Next, the second data set is the border crossing entry data, metadata updated. Here we are using the data set the border crossing data. The summary of it is it consists of all the US Canada and the US Mexico borders at the port level. These data are available for trucks, trains, and the containers, everything. You can see the link here. When it comes to the data set description, in this data set, you can see the absence of comparative data on onbound crossing poses a challenge for analyzing the traffic trends. To address these issues, there is a need for more balanced data set that includes outbounding crossing information, all the transport information, and the managing strategies. The goal for this is to enhance the completeness and the utility of the border crossing entry data by incorporating onbound crossing information. And in the same way, we are importing the pandas. You can see the result here. Here we are having like 3 lakh rows into 10 columns. You can see the port name. You can see the port name, state, port code, border type, data, and the measures of the goods or passengers value, everything. Then we are printing the sum of the data values in the data set, displaying the count of the missing values and everything. Columns such as latitude, longitude, and the point each have one missing value. Addressing these missing values may be necessary depending on the analysis or modeling objectives. When it comes to the data, you can see the output here, the complete column like data, everything, and then the data pre-processing. Data latitude and the longitude, you can see the mean and in place is equals to true. Then we are importing the TensorFlow. The provided code fills missing values to the latitude and the longitude, such as training the TensorFlow model. Then we are splitting the data as we have seen in the dataset one, like X train, Y train, X test, and Y test. Here the code uses the port code, latitude, and longitude as the train test split and the value into the training and the testing set. Subsequently, this standardizes the feature values using standard scale, enhancing that the features have a mean of 0 and a standard deviation of 1. And then we are importing NumPy as NP. Then we are printing the values like X train scaled, X test scaled, and the output of these values. Here you can see the false values. The printed statements confirm that there are not a number or infinite values in the standardized training and testing. The absence of missing or infinite values enhance that the data's numerical stability and suitability for machine learning models. And then the TensorFlow for the data learning. Here we are building a simple regression model using a TensorFlow. As we have seen earlier in the dataset one, it's the same. And then we are compiling the model. Then we are training the model like using the epochs up to 10. Here you can see the loss and the value loss. The relatively high loss values may imply the need for further model refinement or consideration of more complex architectures for improved performance. Can you please scroll down? And then we are evaluating the model on the test set. Here you can see the loss function, and also we are printing the mean squared error on this and making the predictions of the new data. Like we are using the data frame for the port number, latitude, and the longitude. Here you can see the results with the minute per second. You can see the predictive value like 44,236. A lower mean squared error indicates better model performance, and this relatively high value suggests that the model might not generalize well by the test data or require further refinement. Subsequently, the predictions can be further analyzed and compared to actual values to assess the model's accuracy and generalization. Then we are importing the matplot for the graph to be represented using the X label as epoch and Y label as loss. Here you can see the graph here. The orange line represents the validation loss and the blue line represents the epoch loss, indicating that the model is learning from the training data. The close alignment of the training and validation losses suggests that the model may be overfitting or underfitting. Significantly further analysis, such as monitoring loss trends across that. In this here, finally, I can conclude that a data set containing information about various border crosses include port details, geographic considerations, and measured values was analyzed and prepared for the machine learning. The data set was pre-processed based on the value features such as value features. Here the two machine learning frameworks, TensorFlow and pytorch, where we utilize to build the regression models predicting the value based on it. And the pytorch model exhibiting a gradual decrease in both the training and validation losses for 10 epochs, suggesting the learning patterns in the data. However, the relatively high loss values indicating a need for further model refinement of considerations of more complex architectures. The evaluation on the test set revealed a mean squared error of like big value, indicating potential challenges in generalizing to unseen data. You can see the graph here. The pytorch model was finally, I can say that the pytorch model was also trained for 10 epochs and its performance could be compared to the TensorFlow model. However, the code for plotting pytorch training losses was not provided. In conclusion, can you please scroll? In conclusion, I can say that both frameworks were employed for building regression models, further analysis, hyper-tuning, and potentially more complex for model architectures may be necessary to improve predicted accuracy.